Hi, everyone. My name is Mark Meier. I live about 4,000 miles that way.
Hi, my name is Chris Bedwell, and I live about 25 miles that way.
We both work on the synthetic monitoring squad here at Grafana Labs, and we're here to talk about reliability from the outside in and how Grafana can help you see what your users experience. So let's get started. And let's get started with a situation you may have lived through before. You're on call. Dashboards look good. There's no alerts firing. There's nothing interesting in logs. It's plenty of time for us to look at Hacker News. Then you get pinged. You get pinged 11 more times. Apparently things are slow for some users, but you can't figure out why. You recheck your dashboards. You see the system isn't down. It works fine for you. Yet some users are still having a bad experience. Reliability isn't just about system uptime. It's about what your users feel, and that's what this talk is about. How we bring user experience into this picture of reliability. So humans have limits in how they perceive interactivity and thus reliability. Let's represent 10 seconds with a line. Some of you may have heard of this. Jacob Nielsen famously studied this along with some others, but there's three main thresholds we need to consider when optimizing performance of web or any application, any system that users interact with. The first threshold, the point at which systems feel interactive, like you're actively making the system do something. It's 100 milliseconds. The next threshold, the time before it feels like you're telling the system to do something, you're giving an instruction, waiting for it to do something. 1 second. And finally, the limit in holding a user's attention. "10 seconds, really long time. Luckily, we can measure user experience on the web. So to get your attention again, since I gave you 10 seconds to think, I just want to see a show of hands. Who here has heard of Core Web Vitals before? Very good. So these are Google-defined metrics, and they're signals deemed essential for a good user experience on the web. These are just the core ones. Other ones exist. We'll just talk about these today. There's three that we'll talk about. Loading, and they focus on loading, interactivity, and visual stability. We have largest contentful paint. How long for our main content to load? Interaction to next paint. How responsive buttons are, or how sticky they are. Cumulative layout shift. How much is the content moving? Sure, you've all been on a news site before, reading an article, and ad loads, all of a sudden you've lost your place. Super frustrating. So again, good news here, all of these things are measurable. Bad news, the only part of the story. So inside your system, I'm sure many of you have structured things. You have visibility into how the system performs, how it starts to misbehave. Is CPU saturated? Are you running out of memory? Are garbage collecting doing their collecting? Outside your system, there's chaos. We have different networks. We have different browsers on different networks. JavaScript, CSS, rendering differently on different browsers on different networks. Throw in a bunch of different mobile devices, and there's a huge amount of variability. The catch here, users don't care about this variability. They only care if the system works, if they can log into your site, if the button is working correctly, if they can do the job that they need to do. And this is why outside in matters. We want to see things early, understand impact, and validate fixes if we have them. And to be very clear, this isn't about a perfect tool nor a perfect metric, but layering data that we do collect. Let's talk about Swiss cheese. The Swiss cheese model is a risk assessment model for managing risk on systems. The general concept is each slice represents some type of check to make sure that, hey, we'll avoid failure. The core component of it is that no one single slice is perfect. It's not going to catch everything, but you get value from stacking them. There's fewer complete failures if you have multiple checks. And we see this in real life. You're driving in your car, you wear a seatbelt. Roads have speed limits that say how safe it is to go on a road. You have a speedometer to know your speed relative to the speed limit. You have mirrors, your car may have lane assist. There's people out there that may choose to use their blinker. When the worst happens, we have airbags. Reliability works in the same way. Different tools give us different perspectives to make this picture whole. I can apply this model to the entire Grafana stack, but I want to focus on 3 tools today that focus on the user experience. We have synthetic monitoring to detect regressions of critical workflows, Frontend O11y that can help us see what real users are experiencing, or help us validate a blast radius of issues we know are happening. Finally, Grafana Cloud K6, which we can use to gain confidence before we release or before an important event. I want to invite Chris on stage. He's going to be showing a site called Quick Pizza. Does one thing, delivers you the world's fastest pizza recommendation. We'll take a look at web vitals across all 3 solutions. We're going to see that browser checks catch a blip that may be a canary of a larger issue. Frontend O11y will confirm our blast radius. And finally, a K6 test to gain confidence before we deploy our fix.
Great. Thank you very much, Mark. So here we can see our Quick Pizza application. It is completely over-engineered to do one thing really well. We click pizza, please, and it just gives us a recommendation. And let's be honest, it's pizza. We're always going to click love it. But as you can see in our flow here, we have to log in first. So we know that a common user flow is going to be people coming to the website and logging in. And this is where we want to record that user journey in the form of a K6 script using our browser module. And to help me do this, I'm going to introduce our K6 Studio, which is a dedicated desktop app. It's open source software. There's a great team working on it, and they're always eager for feedback. And today we're going to be looking at the recorder. So here, I'm going to click on Record Flow. I'm going to click on our pizza instance. I'm going to ensure that Capture Browser Events is clicked, and then do Start Recording. And this is going to open up a Chrome instance, and you can see our K6 Studio widget over the top here. And I'm just going to drag that over to here. And I'm just going to click through the site like any user would. So I'm going to go to Login. I'm going to type in our highly secure credentials here. And I'm going to click Sign In. I'm going to get rid of that one. We can see all our pizza ratings. We can click Go back to main page. We can go to Pizza, please. Again, great recommendation. We're going to click Love It. And before we finish up, we're going to use one of the widgets up here to have a text assertion that rated has appeared on the page. Great. I can use one of the last widgets up here to toggle the event list. And we can say, yeah, they look OK. So I'm going to stop the recording. So now we go back to K6 Studio. And you can see that during that whole session, it's recorded every single event with all the different requests, whether it was our static CSS, our images, our JavaScript, even our third-party dependencies. But one of the things that I really like about an end-to-end user test like this is it captures all our API endpoints as well. So you can see that there's 11 of them, which we can assume were all essential for that user experience. And a testing from this perspective of a user is completely implementation agnostic. So if these endpoints were ever to change to a version 2, or we were to ever update the routing for them, it wouldn't matter. This test would still endure. So now that we have those, we're going to click Create Test. We're going to export the script. We can see it here. And then just before we take this script over to synthetic monitoring, we're going to go to our IDE of choice. And I can see that cursor is trying to tell me what I want to do here. So I'm going to import the check module here. And this is going to allow me to put an assertion on this whole user experience that I want it to take less than 6 seconds on a whole. Now, no human is ever going to run through this quicker than 6 seconds. But what's nice about having a deterministic bot is as long as our APIs are behaving correctly, it will do it in a very similar amount of time every single time. And to test that, oh, have I got it? Here it is. So to test that, I'm going to use the K6 CLI, and I'm going to have an environment flag here for K6 browser equals false. So this means that it's actually going to load up a visible Chrome browser for us to watch, and then I'm going to run the test. So it's very much blink and you miss it, it goes through, and it's finished. And we can review the CLI output here. We can see that the assertion that we added is successful, and we can actually see that iteration duration took less than 4 seconds. So that 6 seconds we had is plenty of wiggle room for it. So now that we have our script and we verified that it works, we can go over to our Grafana Cloud instance. And we're going to navigate to synthetic monitoring and to checks. So I'm going to add a new check. we've got several different check types. Obviously, we're focusing on browser today. I'm going to paste my check in. I'm going to add a job name and instance so that our telemetry is uniquely identifiable. In our wizard form here, I'm going to go to execution. I'm going to pick 3 probe locations that I think would be interested in pizza. I'll leave the frequency at 5 minutes. And then I'm going to go over to alerting. And I'm going to say alert if at least 3 of 9 probe executions fail in the last 15 minutes. I could add a runbook URL for anybody that was on call or on duty and there was an incident. But I'm a lazy front-end dev, so I'm not going to bother. So just before we finish up here, I'm going to click test, and it's going to run a test for all of those probe locations we've selected. It's worth noting that this view is something that we're working on synthetic monitoring. This is a preview build, so it's not quite what you'll see in production right now, but it will be coming very soon. And great. We can see here that all 3 of them were successful, and we can see that the duration, again, is well under the 6 seconds, and they all passed. So now we can save that test. And if you thought that 10 seconds earlier for Mark's part of the demonstration was long, wait until I make you wait 10 minutes for synthetic monitoring data to come in. Don't worry, I've blue-peated this, and here's what I made earlier. But before we look at that dashboard, I actually received an alert over the weekend telling me that there was a degradation in this service. So now I'm going to go to the dashboard, and I'm going to apply that time range. And we'll go back to here, and this is our new dedicated time point explorer visualization for synthetic monitoring. And just before we look at this in a bit more detail, I just want to draw your attention to 2 metrics up here in particular, which is uptime and reachability. So uptime is asking the question, for any given period of time, or time point, did we just get 1 success or not? And if so, mark it successful. Where reachability is maybe our more traditional idea of like uptime monitoring, which is asking of all the executions for that time period, what percentage of them passed? And when you see a discrepancy like this, it paints a picture very quickly that there's probably a regional issue. So we can confirm that going down to our time point explorer, and we can see that the alert started firing just after 5 o'clock. And we can start to hover to get some tooltips here. But instead of hovering over all of them, I'm going to move to our reachability view. And I'm just going to disable our alert annotation here so we can see. And here we can start to see the picture unfolding. We can start to see that our London probe started failing. We can either go over to the mini-map here, and if we ignore some of the outliers and have a look at the apex, we can have a look at the logs for that probe. And we can see that the user journey is taking almost 22 seconds at this point, much more than the 6 seconds that we had allowed for. We can continue to have a look down in the dashboard here to have a look at some of the other metrics. And right now, as I have no filters applied, our web vitals look OK. But if I was just to go up and I was applied to our London probe, we can start to see how they start to degrade. But synthetic monitoring, there's a double-edged sword to it. It's great because we control and we understand every single variable that is going in, and we know the result that we want to come out. But it's not really telling us the full picture of what's going on with our real users. And for this is where we go to our second product, which is Frontend Observability. So Frontend Observability is our RUM solution, which stands for Real User Monitoring. And this is where we'll be instrumenting our web applications, and they'll be sending telemetry back for our real users. So I'm going to apply the same time range that we just saw in synthetic monitoring. And again, we can start to see that our web vitals are degrading here. And just to try and confirm what the blast radius is, I'm very deliberately going to select everything that is not the United Kingdom. And I can see these all look really healthy. So now I'm going to remove all those filters and just put the United Kingdom on. And then here the picture's really told to us. And we can see that our web vitals have really degraded hugely. We can see that it's instrumented our homepage and our login for the web vitals here and how they're responding. We can see how many page loads and how many errors we have. And we can see the error rate is staying fairly flat. It's not a case that our service is erroring. It's a case that our service has degraded and its latency is huge. The times here, I think, paint quite a compelling story that as dinner time is approaching and people are coming to our application for their pizza recommendations to know what to have that night, the more people that are coming on the site, the slower the experience is becoming. And now armed with this information, before we hand it over to our devs, we can also just go to the HTTP tab here, and we can have a look and see whether any of our API endpoints are affected as well. And we can see that our pizza recommendation route had an average of almost 1.75 seconds there, much, much higher than any of the other API endpoints. So to recap where we are at this point, we've used synthetic monitoring. That's given us an early warning sign within minutes that an incident has started. We've gone to Frontend Observability to confirm the blast radius. And now on that information, we can give it to our devs, who can now try and reproduce this in a lab-like environment. So just before we navigate it to Grafana Cloud, I just want to introduce what the K6 script that we're going to be using here to reproduce it. So a K6 script is written in JavaScript. In this case, it's actually written in TypeScript, which is supported natively now. And I'm going to be using what we consider as a hybrid test. So I have 3 scenarios. The default scenario that I've dictated here is exactly the same script as that we use for our synthetic monitoring check that we recorded in K6 Studio. And all I've added is 3 different stages to start to try and replicate the load that we saw in production. So it's going to last for 3 hours. And we also saw 2 problematic endpoints as well. So one was the login HTML route, where it's also going to run for the same amount of time. And also the pizza API route that we saw was problematic as well. No test is going to be any good unless we define what its success criteria are here. So I've put in 3 thresholds where I've said that HTTP errors have to be less than 2%, that 95% of the requests should be below 2 seconds, and 99% of the check should be successful. I've also added 3 different load zones as well to see whether I can replicate these results in different areas, despite we only saw it in London with our London and our UK users. So now going over to Grafana Cloud K6. We're going to go to our Quick Pizza project, and we can see the 2 tests that I ran here. So the first test is before our devs had deployed a fix, and we can have a look at the results. And here we can see that they've replicated with lab-like data exactly what we saw in production. That as our request rate went up significantly, so did our response time. You can see that we made almost 110,000 requests over the 3 hours there. And we can also see, because it was a hybrid test, what the web vitals returned as well for what that all-important user journey. And we can see that these are quite highly degraded too. One last thing that I didn't show you in that script is that we also introduced the screenshot API. So I can go and spot check any of these iterations and get some idea of what's going on at the time. So we can see here, this is what our homepage looked like after a second of loading or so. We have the thresholds down here, so we can see exactly by what margin that they were failing by. And now that our devs went off and we've given them this information and they've reproduced it, they've gone away, they've done a fix, we can go back to our project in this test run and we can rerun exactly the same test with 0 modifications. And we can see a huge performance increase where it's finished absolutely fine, when even despite when the load and the requests went up significantly, the response time still stayed flat. And we can have a look as well at the browser vitals, the browser web vitals, and we can see that these are all very healthy in the green as well. We can even use the comparison feature here in Grafana Cloud, so we can see the exact differences. And go over to the thresholds and see that we actually had a perfect check rate versus 56% previously. And then there we have it. There is our 3 cloud products working all together. So Mark, back to you.
So as Chris just showed us, reliability isn't just about uptime, pure uptime. In our case, the site was never down. It was just slow. This was kind of tricky to detect. Some of our pizza lovers saw degradation, but not all pizza lovers. No tool told the entire story what happened. They actually worked together to signal the problem, validated that it's real, and verified a fix. So together, these tools can help us maintain fast, reliable, and predictable experiences. So we showed you a lot of things today, and before we get to Q&A, we do want to tell you about some things we've been working on in these products. Let's start with one of our most requested features this year. We've integrated synthetic monitoring with the Grafana Secrets Management Service. You can store tokens, certificates, other sensitive data in Secrets Management, inject them into a synthetic monitoring test in your requests, automatically redact those so they're not visible in metrics or logs. This is in public preview, so you can go use it today. It's widely available. Next, in the demo, Chris showed the time point explorer. So we eventualized executions in synthetic monitoring. We want to make it easier to understand failure. This is coming very soon, over the next few weeks. It'll ship to all Grafana Cloud accounts so you can make use of it. Our friends in Frontend O11y have been working on a feature called User Actions. I think Manoj may have showed it to you yesterday. This allows you to link key steps in user flows to telemetry so you can spot reliability issues in these important workflows and focus on resolving those business impacting issues.